and Shojib by ID 94. This is the five-way traffic junction located at Bangla Motor. We intend to design an automated traffic control system at this junction. The design will include red, green, and yellow light at each road. These lights will operate in a systematic manner. Pedestrian crossing guide through LEDs and a 7-segment display will show the remaining time of red signal. These are the components used in our project. Some notable components are 555 timer, IC 4017, a decade counter, IC 4510, BCD up down counter, IC 4511, 7-segment driver, and 7-segment common cathode LED display. This is the flow diagram of our project. This is the at first clock pulse has been generated by a 555 timer IC. Pulse width can be controlled through a potentiometer. The output pulse is then fed to a decade counter. It counts 10 decimal points from 0 to 9. The 10 output pins are directly connected to the green and yellow LEDs of each road. When green and yellow both LEDs are off, pedestrian crossing white lights turn on, and when green or yellow LED is turned on, the pedestrian crossing red light is turned on. This operation can be easily obtained by a OR and a NOT gate, which is shown in the schematic diagram beside. Now the pulse generated from 555 timer is given input to the BCD counter. It is operated as a down counter here. Output from BCD counter is fed to a 7-segment driver. This driver turns on the correct segments of 7-segment display according to an input. For example, if an input is 1001, that is 9 in decimal, it would turn on A, B, C, F, and G, which will finally show 9 on the display. The basic schematic diagram is shown beside.
For clock pulse generation, we are using the 555 timer in a stable mode. By using a couple of resistors and capacitors, we made the 555 timer to work in a stable mode. Since the duration of output being high or low is dependent on charging and discharging times of the capacitor, we can control the duty cycle and the frequency of the output pulse by using a potentiometer in place of R2. If we vary the potentiometer, we can vary the time period, on time, off time, and the duty cycle will be varied accordingly. Thus, by using 555 timer, we generated a PWM clock pulse and fed this clock pulse into the CMOS decode counter divider, which is IC4017. IC4017 is a CMOS decode counter that can count from 0 to 9, and its output are decoded, which saved a lot of board space and time required to build our circuit. Here the output begins from 0 and moves to output 9. Once it reaches, then the output will count at 9, and again it repeats from 0 and continues this revolution. On each count among 0 to 9, the particular output pin can include high state and the remaining output maintains low. Simply one output will be high at a time. If we want to count from 0 to 8, then we will connect the 9th output pin Q9 to the master reset, which is pin number 15. In our project, there is 5-way, so we will need minimum 10 output, so we are using all the output pin. We provide clock from the output of 555 timer. In our IC4017, there is a disable pin, which is pin number 13. In the normal mode of operation, this is connected to ground or logic low voltage. If this pin is connected to logic high voltage, then the circuit will stop receiving pulses, and so it will not advance the count irrespective of several pulses received from the clock. I will now describe about the IC that is used in display. IC4510 is an edge triggered synchronous up-down BCD counter. It can count up or down in BCD pattern depending upon the input state. It has 4 input and 4 output pins for the respective BCD input and output. The 4 outputs carrying the BCD output are obtained at pins Q0, Q1, Q2 and Q3. Here we gave clock pulse from the 555 timer to this BCD counter in pin number 15. If we set pin 10 to logic high voltage, then it will act as up counter, and if we set pin number 10 to logic low voltage or ground, then it will act as down counter. If we want to count 3 bit, we will connect Q3 to the master reset, which is pin number 9. It sets output to 40. Every time the clock pin goes from low to high state, the output increase or decrease by 1 depending on the state of up down pin. IC4511 is a BCD to 7-segment decoder driver. Its function is to convert the logic states at the output of up-down BCD counter into signals which will drive a 7-segment display. The display shows the decimal number 0 to 9. 7-segment display is made of 7 different illuminating segments. These are arranged in a way to form numbers and characters by displaying different combination of segments.
So this is the final simulation file of our 5-way automated traffic control with RGB LEDs and only with digital logic circuit. We have 3 major parts in our project: the 555 timer to make the clock signal, controlling the traffic light, and showing the digital count with 7-segment display. We start by creating clock signal using a 555 timer IC. A potentiometer is used with the 555 timer IC to control the clock pulse. The clock pulse is passed through a SPDT switch. One through of the switch is connected to the clock and the other through is connected to a power supply. And the finally the pole of the switch is being connected to the counters. The entire system can be paused and resumed by operating this switch. Now we utilizes a decade counter to manage the traffic light IC4017. There are 10 output lines on this counter. We use all 10 output because we have 5-way traffic light. Here we define the first output pin as J01, which indicates the first green LED, and the second output is named as Y01, which stands for first yellow light. And this same convention is followed for all the output pins. After that, we used a 100 ohm current controlling resistor to connect all our LEDs, and we named the LEDs pin as the counter output pin to short them without making wire connection. By this connection, we can drive all the green and yellow LEDs sequentially. Then for red LED, we have used a 2-input OR gate with G0N and Y01 as input. After that, we added a NOT gate. The output of this NOT gate is connected to the red LED. Here, we have followed a simple logic to make the red LED on while green and yellow LEDs are off. Again, for pedestrian crossing, when the red LED of the roads are on, then the white LED will glow on the pedestrian crossing. And if the green or yellow LED is on, the red light of the pedestrian crossing will turn on. After that, to show the count delay for the green LED become on for a certain road, we have used 7-segment display. And to drive the display, we have used a BCD counter IC number 4510 and a display driver IC 4511. The counter is being supplied from the same timer circuit. Now, here you can see our project simulation in action.
This is the 5-5 timer IC. Here we can change the pulse width by varying the potentiometer. The generated pulse from the 5-5 timer IC is then given into the 4017 decade counter IC. This counter is counting from 0 to 9 according to the pulse interval. Then the output pins of the 4017 decade counter is fed into the required OR gate and NOT gate to controlling the traffic light signals. Now for pedestrian crossing signals, when the red light of the traffic signal will turn on, then the pedestrian white light will also turn on, and other times the pedestrian red light will turn on. Now for the display section, we made another clock signal generator using the 5-5 timer IC. Then the clock signal is fed into the 4510 BCD up-down counter, and this counter generates the required 9 to 0 numbers in BCD form. Then this 4-bit number is fed into the 4511 IC, which converts the BCD number for 7-segment display. Here is the 7-segment display, and it is common cathode type. Here is the full roadmap of our project. These are the traffic lights, and these are the pedestrian crossing light. Here is the full overview of our project. Now we will present a demonstration video of our project. We have some limitation in completion of this project. Due to pandemic, it was very difficult to work in a group. We bought the components from the local market, and those are not that good. After testing for several times, many components get damaged, so we needed to replace them a few times. There are some future plans that we can initiate. We can add some isometric barrier on the left side of each road. When a red light will turn on, the barrier will block the road so that no vehicle can cross the road. Because in our country, most of the people don't abide the traffic rules. Also, we can control the red, yellow or green light for different time settings. We can also use computer vision so that the system will sense in which road the traffic is most. Then it will open this road for much greater time comparable to others. Thank you everyone. If you have any questions, then feel free to ask.